languages. This means that every value has a specific type. The meaning of a value is determined by its type. A data type consists of both the size and the interpretation of a value. For example, the int type means a natural machine-sized integer value. That'd be 32 bits for a 32-bit machine. An unsigned int means the same size integer with no bit reserved for sign. Built-in types for C and C++ include integer types for representing integer numerical values, floating point types for representing real numerical values, and the bool type for representing Boolean values true and false. This type is available in C++, but not in C. C++ also provides constants called true and false. And beginning with C99, C provides a built-in type _capital bool and a standard header, standardbool.h, which uses macros to provide bool true and false. This is designed to mimic the behavior of C++'s bool type without breaking existing code that has traditionally provided this capability with macros. C and C++ also provide some compound types, including arrays. An array is a contiguous sequential set of objects of the same type. C and C++ arrays are very powerful, flexible, and have very low overhead. They're also the basis of C strings and the C++ STL container types. A structure is a sequential set of objects of various types. A structure may contain scalars, arrays, and even other structures and classes. C++ classes are based on C structures, and technically a class is a structure that defaults to private membership. In practice, a class is a structure that contains function members as well as data members. We'll discuss these distinctions later in the course. Classes are available in C++, they are not available in C. A union is a set of overlapping object types. This allows a single object to hold objects of different types at different times in the same space. A pointer is a reference to an object of a given type. The pointer itself typically holds the address of the object it points to. Pointers are strongly typed in C and C++. The type of a pointer is used as the type when it's dereferenced, and it's also used to determine the size of increments, decrements, and arithmetic operations on the pointer. C++ also provides a reference type. This is not available in C. A reference is very much like a pointer, but with different semantics. The major distinctions between pointers and references are that references are immutable. Once they're defined, they cannot be changed to refer to a different object. And references are accessed as aliases. A reference is accessed without any syntactic indication that it's a reference and not directly a variable. This allows for silent side effects. We'll discuss the C++ reference type in more detail later in this chapter. Note that neither C nor C++ define a special string type, though both languages have provisions for handling strings of characters. We'll cover both types of strings in this chapter. C and C++ provide a number of fundamental data types that may be used or extended for many purposes. The rest of this chapter will cover